Hey grip friends, I've got another video here about braced bending, an idea that popped into my head. I was looking at my monster pile of braced bending steel and I thought, man, that is a lot of steel. What could a fella do with something like that? Of course you could make some artwork out of it, you could always recycle it, you could repurpose it. If you're really strong, you could do some snapping with it. But of course the thought entered my head, hey, if you're going to bend a bar, let's say 5/8 of an inch by 36 inches, why does the bar have to be 36 inches long?
Well, if it's not 36 inches long, it's something else.
Okay, fair enough. But let's say you're going to bend that piece of 5/8 and it's shorter than 36 inches long. If you had some sleeves that you could slide over the ends of that bar that would make it 36 inches long, well, that would give you the proper amount of leverage for what you're expecting for a 36-inch long bar. And it would save you on steel, which would save you money. Now that's the subject of today's video, so let's dive in.
Okay, so the first step in solving this problem is determining what is the minimum length of steel that we can use. Now, we need to know what that length is because we want the bend to feel like a normal bend. But we also want to save some steel. So here's the method I use to determine what the minimum length of steel is. Okay, so I started by measuring this distance here, right where the bend stops and the bar is straight. And I figured that would be the diameter. And I measured quite a few pieces of steel. This isn't all the data, but it's a lot of the data. And I compiled that for an average of 5.5 inches in diameter. So I'm thinking of that as the diameter of a circle. Now why is that important? Well, we can calculate the circumference. Circumference is 17.25 inches. So if you bent that into a complete circle, it'd be 17.25 inches. Alright, now if you're thinking, okay, so why is that important? Why would I care about that? Well, just hang with me for a minute, because what I'm figuring is that half of that circumference is going to be our minimum length of a bar, or a big component of the minimum length of a bar. So half that circumference, or 8.625, 8 5/8 inches. Okay, so if you're still like 8.625, why do I care? Well, here's why. That's what this distance is. And we're going to find that's really important. So here's the concept. That rectangle in the middle is the bar that you're actually going to bend. Now we've just determined that 8 5/8 is that length. Now, I want to solve for the rest of this so we can determine what these sleeves dimensions are going to be and what the handles are going to be. Now I know I haven't defined a lot of these terms yet, but I think you can figure it out as we go. So let's start by solving for the total length of what this is going to be, which I've decided is going to be 30 inches. Okay, so I don't want to insult anybody's intelligence here, so I just went ahead and did the math and spared you the pain of all that. But total length, like I said, is 30 inches. I think the handles need to be 4 inches long at minimum to get a good wrap on it. So the sleeve I've determined 6.875 inches long for each of the sleeves. Here's the big picture, right? So the bar is set into those sleeves. Now we need to revisit the minimum length of the steel that we're going to bend. Now I reckon that the steel needs to set into the sleeves by 1.5 inches. At least that's the minimum. How did I come up with that number? I just did. So I brought you this far, just trust me. So 1.5 inches on both sides of the steel, 11.625 inches. Okay, so the next portion of this video is going to be in regard to the sleeves themselves and how I went about building them. So be patient, it's kind of tedious. So I started with 1.25 inch drawn over mandrel tubing, 1/4 inch wall. Should have an internal dimension of 3/4 inch. Now I should have mentioned this earlier, but I decided during the design process that the handles would be 3/4 inch in diameter, and unfortunately that doesn't telescope inside the tubing as is. So a little bit of predicament there, but I decided to remount the tubing on the lathe, and while I was at it I thought, hey, you know, removing hot rolled mill scale really sucks, so why don't we just do that on the lathe? And it sure did a pretty good job. Okay, so once that was done, I drilled and tapped the holes to accept a set screw. This is what's going to hold the steel bars and the handles into these sleeves. Now, funny story, so I misplaced the T-handle for my taps, and I thought I'd improvise by using the locking pliers. Yeah, we know that trick never works. So I improvised once again because I broke a tap off inside the sleeve by using this beam clamp and a bolt. Now I know somebody out there is probably thinking, yeah, that looks like that worked a whole lot better. Well, your sarcasm has been noted, and you should know that I was able to tap all 8 holes with this method. It actually worked really well, believe it or not. Okay, so if you're lost at this point, I bet you finally figured out what's going on here. So the set screws are going to hold the bar that we're going to bend, and they're also going to hold the handles. And this is going to allow these handles to telescope in and out to change the length, the total length of the bend that you're going to do. So this is going to give you some versatility in your training so that you don't have to bend a full 36 inch, 30 inch, whatever the diameter is. You don't have to bend the whole thing. You can just bend that minimum quantity we talked about earlier, and you can use these handles to adjust the total length for your leverage. Okay, now if you're starting to get bored, don't touch that dial because this is where things start to get interesting. Here's the idea, alright? Those handles are adjustable. They can telescope inside those sleeves. I've got a bar here that's 5/8 by 34, and I've got this piece of steel that's mounted in the sleeves that is 5/8, but it's our minimum bending length. And you can see that both steel bars are the same overall length. So now let's rate it, see how it turns out. Okay, so here's my method for rating, and I use that term loosely, this steel. You can see I've already started to bend it, and I realized I need a little bit more weight. I'm trying to hold my hands right at the edge of the wraps here. And there's most likely more sophisticated method if we're doing this, but the reality is I have no plans to continue to rate brace bending steel, especially as much variation as there is with hot rolled. So this was a method that was easiest, and it did produce some results that I think could be replicated. Now you can't see the scale real good. I zoomed in. 317 pounds to get it to 30 degrees. So here I am with the bar that's in the sleeves. So fingers crossed, we'll see how it turns out. And what do you know? It's almost like I planned for it to be that way. Okay, so the rating comes out really close between the two bars. The next question is, how does it feel when you're actually bending it? Because the rating is kind of like RGC. You know, RGC tells you absolutely everything you need to know about a gripper. So that rating probably tells me everything I need to know, right? Well, I'm going to go ahead and bend this. And here's my impressions. First of all, I did some brace bending yesterday on some bars that were a little bit shorter than what I'm working with now. This is well within my realm of where I can normally bend. 5/8 by 34 is a pretty safe bend for me. And so what I'm thinking is that I am not going to brace bend for volume or any kind of training by any other method than what I'm doing right now. And the reason is, first of all, those sleeves are a little bit wider, so they don't tear your leg up as much. I found that I didn't really need the padding. I did more bending than what I showed in the video here. This is just for demonstrative purposes. The other reason is, the feel of it was flawless, just like braced bending. So that makes me ask, hey benders, which would you rather do? Why would I continue to bend the full length of steel for training only? Now a certification bend is obviously different, but why would I continue to bend the full length when I can just bend this. Okay, back to the whole point of the video, to save money on steel. So I went to Online Metals and I pretended like I was going to buy an 8-foot long piece of 5/8. Believe it or not, I tried some shorter pieces. The shipping's not that much different. So $40 for that one piece of steel. And depending on how you cut it, you might get 3 bars. Probably going to get 3 bars, maybe 4, depending on what level bender you are. Now, if you were to cut those to our minimum bending length, just rounding up to 12 inches, you'd get 8 bars. So, which would you rather have? 3 or 8? Okay, real quick recap because I don't think I touched on this very much. The handles telescope inside the sleeves, so you can change the total length of the bar that you're bending. Now, your maximum length of your bend, 37.625 inches. Your minimum, 30 inches. Now, what if you wanted something shorter? Well, I could get shorter pieces of 3/4 or no handles at all. So this has been a pretty long-winded video. I hope you enjoyed it. I hope you got something out of it. And most of all, I hope this will revolutionize the way you think about braced bending, because if you want to get some volume in without breaking the bank, I definitely think this is a way that you can do it. Thanks for watching.